Hello and welcome back. I have two more concepts associated with the flu virus that didn't get into the last video, so I'm going to do it just as a new short video here. So the two things that are associated with influenza A are genetic drift and antigenic shift, okay? And it's something that just occurs with influenza type A with those H and N glycoproteins with the hemagglutinin and the neuraminidase. What happens? And the basic difference between drift and shift is how big the change is associated with the virus, or at least that's part of it, okay? With drift, as that virus replicates inside your cells, making you sick, mutations occur, okay? And the mutations are occurring in those H and N glycoproteins. So what happens is they're a little bit different, all right? And that small change is referred to as genetic drift in the virus. So the virus that infects you may be just ever so slightly different than the virus that you sneeze out on somebody else, okay? It's small changes that happen in either N or H, but typically it's not a big enough change that it's still classified as the same type. So if it was H1N1, it would still be H1N1 when it's released from you. It's just there are very, very small changes that happen over time. And this is in part also why the flu virus is updated every year, is because of drift that happens. The other part that's associated with the flu virus that also requires updating is the antigenic shift. This is a bigger change. And it's different in how it occurs. Because remember I said with drift, this was happening inside your body. Antigenic shift is going to start in the animal. Whether it be pig or bird, okay? Swine or bird flu are the two most common that are associated with it, where the virus can exist within the population, okay? And that antigenic shift, what ends up happening? The virus changes, so you do get some antigenic drift that happens. Plus, okay, that animal also gets infected with a human version of the virus. So the virus that changes, we'll use pig as the example, all right? The virus that's inside the pig, that's making the pig sick, is a pig-based virus, meaning the tags on the outside of it are going to trigger the immune response and only going to enter cells associated with the pig, all right? But those tags are similar enough that a human virus can enter. And what happens when you get two viruses inside the same organism, and I'm sorry the blue is squeaky, but blue is my favorite color. You get recombination that happens between the two viruses, okay? And what happens with that is because you've got replication, of both viruses inside the same animal, some RNA from the human is packaged. That's a D. Packaged. With a virus from the pig. So what you've got is a totally new combination that comes out of that, okay? And when there have been global pandemics associated with the flu, like, the Spanish flu that happened in 1918, which wiped out roughly 3 to 5% of the total world population at the time it happened. But that was an example of antigenic shift happening. You had a new strain of virus that came out because that recombination in the animal now allows that new combination to jump from the pig to the human and makes us sick. All right? So antigenic shift is the bigger deal. It's the bigger change. Can result in a flu virus that is much, much more potent and wouldn't be part of a flu vaccine. When H1N1 came out, gosh, it was several years ago now, that was another example of something that wasn't covered under the flu virus because it was something new, okay? So antigenic drift, antigenic shift, I want you to be able to differentiate between the two and explain to me how they differ, what happens within the cell. Drift, small mutations that occur, this occurs just within humans. Shift, you need to have another animal, virus has to start in the other animal, combines with human, makes a whole new combination, okay? Hopefully that made sense. If you have any questions, please let me know.